Great. My dear students, let's look at this concept as well. We've previously talked about domain of functions. In our previous lesson, we talked about domain of polynomial functions, domain of rational functions. In this concept, we are going to look at domain of radical functions. Domain of radical functions. So if you are given f at x to be square root of j at x, then how do we find domain? As we previously said, that when we ask you to find the domain of a function, we are looking at all possible values of x that make the function defined. It means that if you plug those values or substitute the value of x in the function should be defined. Other than that, we will not consider it domain. Whatever values that we substitute, after substituting, if the value or if the function goes undefined, then we say that those values are not part of the domain. All right, that is what we are looking at. But before we look at that, let's note this. Now, note that anytime you have square root of a negative value, let's say -1, -2, or all that we say is that anytime you have square root of a negative number, know that we are going to get what? Undefined. Even though we have other concepts like we have imaginary roots, or we have complex number or complex numbers that can deal with negative square root. But in this case, we are not looking at complex or imaginary roots. So if you have this, it means that you are not going to get any solution for this. So take note. In that case, if we ask you to find the domain of a radical function, it means that whatever value you get for this function here under the radical sign shouldn't be negative. Yes, that is what we are saying. Whatever value you get, whether you get square root of 0, you know that it's still what? 0, because square root of 0 gives you 0. If you get square root of 1, once you realize that the value in the radical sign is not negative, then the function is what? Defined. And that is what we are looking at. So take note of this. All right, great. If we know this, then we can proceed and look at how to find the domain of a radical function. So in this lesson, I'm going to take you through how to write the domain, a simple theme. We shall also write the interval notation form when you are writing the domain. Okay, that is what we are going to do now. Okay, so for domain in the SHS level, when you are asked to write the domain, we always say domain should be given as what? X is such that X belongs to all sets of raw numbers. So if we are saying that whatever we have here should not go negative, then it means this j at x you see here should be either greater or equal to 0, because that's what we are saying. Any number or any value of this function should be greater or equal to 0. That will make what? The function defined. If it is not like that, any other things other than this will make the function what? Undefined. And that's not what we are considering. Okay, if that's the case, then we can say that our domain is given as what? J at x should be greater or equal to 0. That is our domain. All right, great. But before we look at this one, you are just giving a function. We don't know what the function is, but all that we are saying is the values of this of x should make the function f at x defined. That's what we are saying. So let's take some examples and see how we can do that. All right, okay, great. Now let's look at the following example. So we are going to look at how we can find the domain of the given functions. So we have example one, which is f at x, giving us what, square root of x plus 4, and the rest what, full. So we shall take them one after the other. In the first place, we shall deal with example one. Okay, all right. So for my solution, good. So if we are given this function f at x equals square root of x plus 4. So we are saying that we should find values of x that will make the function what, defined. So all this you see here, the x plus 4 is another function. For it to be, or for this function to be defined, then the entire value shouldn't be what, -1, or the entire value should be greater or equal to 0. If we know that, then we can find the domain. That is what we are saying. If that is the case, then I will take everything in the radical sign, which is x plus 4 should be greater or equal to 0. Yes, that is what we are saying. Now, in simple inequalities, if we have this, then we can just either we transpose this, or I can just subtract -4 from both sides, and this will give me x greater or equal to, because this one will go, 0 minus 4 gives me what, -4. Good. Now, this is what we have gotten. When you get the answer, you need to test to see whether this condition satisfies this, whether it will make the function defined. If it doesn't make it defined, then we change what, the inequality sign. So I'm going to use the number line to test. All right, always when you, after solving and getting your answer, you don't just have to end there, you need to test and see. So if we are saying x should be greater or equal to -4, then let's say this is my number line. Let me identify my region, which is 0, and where, let me indicate here as my -4 here. Good. Now we know that if I'm to draw a number line, we are saying that we are looking at numbers that are greater or equal to 4. So let me draw the number line. Which side? We know that on the number line we have the negative side and the positive side. At our left side we have for the negative side, and the right side should be what, the positive side. If that is the case, then x being greater or equal to -4, then I'm looking at my right side, so my number line should face this direction. Okay, and then we also have the left side here. Now if I'm to write the inequality, I will say this portion should be greater or equal to -4, or this side from -4 here, or satisfy this, and then here becomes what, my x should be less or equal to -4. We know that this is, I should shade this because we are saying that the -4 is inclusive. Good. So you need to find the values from here and here and test to see which of the directions satisfy the condition. If we are saying that for my left side, I have this here. If we are seeing values here are less or equal to 4, then I can pick values here. If I have -4 and 4 should be greater or equal to x, then if I pick -5, we know that -5 is less than -5. So let me substitute -5 into the function given. Okay, it means wherever I see x, I'll put -5 there. So I have my -5, and then I have my 4 plus 4. And this gives me square root of -1. Remember, I said the moment you get a negative number in the radical side, then the whole function goes what? Undefined. So it means that once we have gotten a value here, if you pick -6, you realize that you are still getting negative numbers. So this suggests that the left side doesn't satisfy the condition. So we are not considering the left side. Now let's consider the right side. We are seeing numbers greater or equal to -4. Let's see if I should pick a -4, because it says it should be greater or equal to 4. So if I should pick x to be -4, let me put it there. My x is -4 plus 4. So you realize that I'll get 0 there. It satisfies the condition. Let me pick x to be, so I'm moving to the right direction. From -4, then I'll pick -3, because -3 is greater than -4, plus 4, which will give me what? Square root of 1, and that gives me 1. So you realize that as I'm moving, I'll be getting positive numbers, and that satisfies the condition. Since at the right side, it makes the function defined, then I'll accept this region to be what? My domain. Okay. Therefore, this is how I'll write my domain. So I will say x is such that x belongs to all set of real numbers. X is greater or equal to -4. So that's my domain. Now let me write the interval notation. Most of the time in the university level, we consider the interval notation more than this one. In the SS level, most of the time we consider this rather. So for the interval notation, since we are saying that this region only satisfies, then I can right? And it starts from what? 4. So it means the 4, if 4 is -4 is inclusive, then it means that here is closed. Okay, because of this equal to sign, it means that it ends here. It doesn't continue, it ends at 4. So that part is closed. So I will do this, okay, and then I'll write my -4, comma, to infinity, because if you move to the right direction, it means that you go and go and go to infinity. It doesn't end. So I will use the symbol for infinity, and that will be positive infinity. Because it goes and doesn't end, then we can say that it is what? Opened. So I will do this as bracket, okay, and here. So the difference between this and that is that here is inclusive. The -4 is inclusive. You can see that where I start from, okay, but this means that it is what? Not inclusive. We don't know where it ends. It doesn't close. It is opened. So when you see that, it means it is open. Here is closed. And that is how we write the interval notation for the domain. All right. So we shall take our second example and see how we can do that one. All right. Great. Okay. So for question 2, or example 2, we have this. Good. So as I said, that whatever value is here shouldn't be negative. If that is the case, then for the domain, we can only say that 6 minus 2x should be greater or equal to 0. Okay. All right. For this, then we can make it what? Defined. Okay. All right. Great. So if that is the case, then let's solve it as the normal way we can solve what? Inequalities. So I can just subtract -6 from both sides. So this one goes, and then I have my negative 2x greater or equal to, so 0 minus 6 gives me what? Negative 6. Okay, I can divide both sides by negative 2. Okay, we know that this one goes, and know that in a normal inequalities, whenever you divide both sides by negative, the inequality sign changes. If that is the case, then I'm going to have x having this change to 3. Okay, so this is what I have got as my solution, but I cannot just end here. I need to still test to see whether this satisfies the function. So I will use my number line. Let me indicate my origin as 0, and let me bring here as 3. So we know that this is inclusive, so I will say this. So once we have this, then we have this direction here, the right direction and the left direction. For the right direction, we are saying that x should be greater or equal to 3. For the left direction, we say that what? X is less or equal to 3. So this one we need to test. If that is the case, then I'm going to pick for the left side, I'll pick numbers that are less than or equal to 3 and substitute into the value, okay, to see whether it will work. So if we are to test, then I can put 3 here. I can choose 3 because it says it should be equal to. So if x is 3, then I can write 6 minus 2. Then we have what? 3 here. And this gives me 0. And the answer is 0. It is defined. Let me pick another number which is less than 2. I will pick 2. So if I'm picking 2, then I will have 6 minus 2 multiplying 2. And that gives me what? Square root of 2. And that one is also what? Defined. What about so it means that the lefts, or as I'm moving to the left direction, every number I pick will be what? Defined. All right, good. Now let me pick numbers from the right direction. So if I'm picking numbers from the right direction, then I will pick a number which is greater than 3, and that will be what? I'm using 4. So if I substitute 4, I'm going to get 6 minus 2 times what? 4. And that gives me negative 2. And remember, we said that the moment you see a negative 2 in the radicals are done, it means the whole function will be what? Undefined. And that's not what we are talking about. Domain, it should be defined. So it means that this portion doesn't work, but this portion worked. And that becomes our domain. So we choose whatever or which direction or interval, okay, or which range of numbers make the function defined, and use as our domain. Therefore, our domain is x such that x belonging to all set of real numbers, x is less or greater than 3. And for our interval notation, because we are saying that 3 is facing here, going to the left direction, which is hot, we don't know where it ends. So that place is open and it faces the negative direction. So once it is open, then I will have negative, good, because we can determine which number, comma, my 3. But the 3 part is closed, so I will bring this because we have the equal to sign. Okay, so this also gives what? Our interval notation. All right, so we end here and continue in our next videos the other examples. We have 2 more examples to look at, so we shall look at it in our next video. So stay cool and watch the next video for the next 2 questions. See you. Thank you. Bye bye.